Hello everyone. In this video, we are going to discuss about how pointers behave with 2D arrays. So just to understand that how pointers behave with two-dimensional array, first we have to understand that how two-dimensional arrays are stored in computer's memory. As I told you earlier also that when we store two-dimensional array, they are stored in the form of array of one-dimensional array. What does it mean when I say array of one dimensional array? For example, I say that I have an array S52. So this is a two-dimensional array. So as the name suggests, array name is S and it has 5 rows and 2 columns. Okay. So in computer's memory, it will be stored as a collection of 5 one-dimensional array which has 2 elements like this. So this fact helps us to understand how two-dimensional array behaves with pointer. So let's say we declare a two-dimensional array 5, 2. It can be thought of as a setting up a one-dimensional array of 5 elements. This is a one-dimensional array of 5 elements. 1, 2, 3, 4 and 5. And each of which is one-dimensional array. Every element of this one-dimensional array has itself has 2 elements. We refer to an element of one-dimensional array using a single subscript. Yes, when we use a one-dimensional array, we refer it as a single subscript. So similarly, we can imagine S to be a one-dimensional array. Then we can refer its 0th element is S0. Its first element is S1. Second is S2. Then S3 and S4. Then what is S0? S0 is this array, first array. S1 is second array. S2 is third array. So more specifically, S0 gives the address of 0th one-dimensional array. The fact can be like, let's discuss it here. Let's say we have a one-dimensional array int S5, a two-dimensional array S5, 2. So basically this will be having 10 elements. So 5 rows and 2 columns. So this is the basic definition of a two-dimensional array. But now how it is stored in computer memory? 5 one-dimensional arrays. And all are having consecutive memory locations. So let's say 5 arrays. So every array has 2 elements. So how compiler understand it? Compiler understand this two-dimensional array as a collection of one-dimensional array. So this is a collection of 5 one-dimensional array which exactly has 2 elements. Each array has 2 elements. So address starts from here. Let's say this is 100. Integer take 4 bytes. This will be 104. This will be 108. This will be 112 and so on. So now because how we refer one-dimensional array? With single subscript. So here when we say S0, S0 will gives us this array. S1 will give us this array. S2 will give us this array. S3 will give us this. S4 is this. So not this. Address of first array. Address of second. Address of third. Address of fourth. Because we know that array name is itself is address. So if I write here cout S1 or I write here cout address of S1 or I write here cout S plus 1. So all are same thing. All are same thing. All will give us address of this array. So what is the first element's address? That is 108. So in this way we can reach to every row of a two-dimensional array. In this way we can reach to every row of two-dimensional array. What is left? Left is reaching to the every element of every row. Okay, so now first let's see this on Visual Studio. How does this work? And then we will move further. Okay, let's declare a two-dimensional array. And let's say I declare a two-dimensional array 3, 2, which is having 3 rows and 2 columns and which is having like 6 elements. And let's declare 3 rows and 2 columns. So let's say 2, 4 and then let's say 3 comma 6, and then let's say 4 comma 8. So now let's write it, because I told you that array name itself is the address of first element. So when I write S0, it is going to give us address of first one dimensional array. When I write cout, ampersand S0, both should be same. Or I can write it cout S plus 0 end line, and this should be semicolon. Now let's check. All three addresses are same. See, all three addresses are same. So if we want address of every row, we can simply write for address of first element of every row, we can simply write 0, I less than 3, I plus plus, sorry, I plus plus, and here we can write cout S of I end line. Okay, just for the simplicity I will remove it. So it is going to give us address of first element of every row. So A4, AC and 9C. Okay, now what is left? The left is how we can reach to the, like for example, if I write asterisk SI, so it is going to give us first element of every row, 2, 3 and 4. Let's run it. 2, 3 and 4. So now we have reached up to every row. Now the second thing is that how we can reach up to every column. So now let's discuss how we can reach up to every column, or how we can reach up to every element of every row. So this is the description. Let's say we know that S2 will give us the address of first element in the third row. So because we have 5 rows, S0, S1, S2, S3 and S4. Okay, and every row has 2 columns. So when I write this S2, it is going to give us address of first element of third row. Address of second one dimensional array, obviously 0, 1, 2, 3 and 4. So when I write S2 plus 1, it means I am going to move one direction here. So now it is going to give us address of second element. Now it is going to give us address of second element. Okay, and if I write asterisk here, it means I will move. Well, now I will access the value here. So in place of this S2, I can write S plus 2 also. So everything is same. So similarly, num I is same as num plus I. Asterisk S2 plus 1 is same as asterisk S2 plus 1 asterisk. If you do not write asterisk here, it is going to give you only address. When you write asterisk here, it is going to give you the value. So let's check it. What does it mean? What I say and what does it mean? It's going to give us the value of every element. Okay, now first element of every row. Now let's say I write for int j is equal to 0, j less than 2, j plus plus. This is for row. Now what I want? I want every element of array. So I could write here asterisk si plus j. If I write asterisk si plus j, let's say what happens. Let's see what happens. 2, 3, 3, 4, 4, 5. So 2, then 2 times 3, 3, then 4, 4, then 5. It is not going to give, because we are adding j here. We are not putting the value. As soon as I write here pointer, See, 2, 4, 3, 6 and 4, 8. What happened in the previous declaration? When I didn't write it here and when I write simply like this, asterisk si plus j. So what it was giving us? 2, 2, 3, 3, 4, 4. Just let's check this answer. 2, 3, 3, 4, 4 and 5. Why it was so? Because see, first element is 2. When I say 2 plus 0, it will give you 2. Next time j is 1. So now it is si is still 2 and now it is 2 plus 1. That is 3. Again, now s1 is 3. So it will give you 3 plus 0, 3 and then 3 plus 1, 4. Then 4 plus 0, 4, 4 plus 1. Because it is not going to access this value. It is simply adding something to some integer to this value. So if you want to access the value, you should put it here. Then this si will not work. Then it also should be a pointer. So it should be asterisk s plus I. If I do not put any pointer here, like for example, just a minute. If I do not put any kind of pointer here, then obviously it is going to give us some addresses. 10, 14, after plus 4, plus 4, plus 4, plus 4. So address of every element, 6 different address. So this is how array name behave for two-dimensional array, how array name behaves as pointer. Now the question is how we can declare pointer for a two-dimensional array. Can we declare a single pointer, like for example I declare a pointer int asterisk ptr and I make it no. What is the method how we can assign a pointer to a two-dimensional array? So let's check it here how we can assign a pointer to a two-dimensional array. So this is here. A 2D array is not same as an array of pointers. So you can to one-dimensional array. Actually a 2D array is declared as int. Pointer for a 2D array is declared as int asterisk ptr, and this asterisk ptr should be inside bracket and 10. So it means this ptr is a pointer to an array of 10 elements. So 5, when I write s52, it is having 10 elements. So if I do not write it with bracket, if I write it ptr 10, then what does it mean? It means ptr is an array of pointer 10 pointers. So this is the difference how we can declare pointer to a two-dimensional array. So let's check it. See, just a minute. So now here I declare, in this program I declare an array of 6 element and 1, 2, 3, 4, 5, 6. Here I write asterisk ptr2. What does it mean asterisk ptr2? This ptr is a pointer of 2 arrays. Okay. So with 2 elements. So when I write ptr is equal to array ampersand 0, 0, ptr is equal to ptr plus 1, array 1 plus 0, ptr plus 1. So this is how pointers behaves with a two-dimensional array and how we declare a pointer to a two-dimensional array. So in the next video we will be checking about strings and all these things. Thank you.